So we're going to keep building our sketch. We're going to talk about specifically how to get some geometry from parts into a sketch. So we've made these parts already, but we're going to need some references from the legs to cut the slots into the legs at the cross braces where they kind of interlock. We're also going to create the sketch for the seat. And then we're going to talk about dog boning. Did we talk about that last time? Okay, we'll talk a little bit more about it. We'll show you how to create the dog bones in the corner so that this stuff interlocks and fits together properly. Yes?
Are you going to make another tutorial like you did for the last one?
Yeah, I am. I actually.
I'm a little behind.
I'm recording this right now. Yep.
All right,
okay. So first thing we're going to do, I'm going to create a sketch on one of the faces of my part. Now, this is not always recommended, but it works sometimes. And I'm not going to get into the details of when you should use this and when you shouldn't, but suffice it to say, if you sketch on part of your model that's already made, you got to be really sure that that part is not going to change and it's going to just be there all the time. Because if you sketch on it and then you change something or move that, or that plane disappears, then your sketch is kind of floating and it's like, hey, I was supposed to be attached to this surface and that surface isn't there anymore. So you got to be smart about when you sketch on planes. Usually when we sketch, we want to sketch on the planes of these axes. That's like a better practice. But today we're going to sketch right here on one of the planes. So we're going to say create new sketch. And I'm going to click on one of the legs. And what I want to do is I want to create a rectangle. And I want to create the rectangle right here at this corner. And I have this horizontal line. You could see that my X is kind of snapped to it, but it's not snapping to this vertical line at all. And that's because this vertical line is not in the plane of my sketch, right? This is the leg that's closer to me. It's not in that flat plane. So how do I get it so that when I drag this over, it snaps to the corner here where those two lines intersect? I have to do something called projecting those lines from that object. So I'm going to click on that again because I clicked a little fast. You go to create, slide down to project/include, and then you're going to click on project. Okay. When you do that, click on project, then you can take any geometry, including those vertical lines, and put them on the plane we're working on. So when I click on these, I'm going to click on those two. I'm actually, even though these ones were already kind of able to snap to, I'm going to click on those as well. And now I have 4 lines that I want in my sketch. And here we can see 4 selected. And we have this thing called projection link. Projection link means I pulled these lines from this object. If that object changes, my projection lines should change as well. And that's what I want, because if I make the boards thicker, I want these lines to move. So I want to keep that checkbox checked. There will be times when you're trying to make something, but you don't want them to be linked together. This new thing is going to be its own thing, and you're just pulling some information from another object. And then that object, maybe even you're going to delete that other object. It's just reference. Then you want to uncheck this. But for now, we want it. We want every change that we make to affect this sketch. So hit OK. And now if I hide those bodies, you can see I have, it looks like I missed one of them. I have 3 purple lines. So I was missing one of those. Let's go back. I'm going to undo that. I'm going to go to create, project include, project. I'm going to click 1, 2, 3, 4. 4 selected, hit OK. When I hide the bodies, I should see all 4 lines. There they are. Purple lines, all 4 of them. And now when I create this rectangle, it'll snap to both the vertical lines and the horizontal lines, and I can start it right at the corner. And now I'm just going to go down by leg width divided by 2. And I'm going to go to the right by material thickness. And there it is. And it's all black because its geometry is fully constrained. That black dot is the corner. It's locked to where those 2 lines intersect. And we're done. And that's all I need for this sketch. I'm going to say finish sketch. And now if I come back out, I show my bodies. remember, each body is kind of imaginary, like just passing through one another. We can't have that. So we need to cut this little notch. And to do that, I'm going to use the extrude tool, and I need to get to that part of the sketch. It's kind of hidden by, I can't click on it because one of the bodies is in the way. So let's move that body. Now I can click on it and watch what happens. If I extrude this by material thickness, that looks like it's going the wrong way. So I'm going to make it negative material thickness to make sure it's going. That looks great. It's right in the right place. You might think, okay, just hit OK. Look, there's a hole in the top of my 2 legs. That means that when I cut that, it cut out of both, and it cut both of them on the top. Not good, because the bottom is still kind of passing through one another. That's not what we wanted. So we can go down to our timeline, and we're going to right click on that extrude, and we're going to say edit feature. And when you look on your feature properties, objects to cut, you can remove one of these objects. So you can tell it I'm only cutting through one of them. Or you can just click on the objects themselves over here and hide them, and then you won't be able to cut them if they're hidden. So this is the one I sketched on. That's the one I want to be cutting. Hit OK. There it is. And now the other body has not been cut yet. So now I can do the same exact thing for this one. I'm going to click on it. Let's reveal that other body. I'm going to include those projection lines. Click on the 2 horizontal. 1, 2, 2 vertical. 1, 2. Hit OK. Now I'm going to make that rectangle from the bottom. Grab that bottom corner. Up by leg width divided by 2. Oh, when you hit tab, that lets you jump from box to box, the tab button on your keyboard. Okay, so whether I typed in that box or not, I could always hit tab. Some people were asking me, how do I go to a box without filling in one of the boxes? Tab is the way to do it. So material thickness, and hit enter, and now I have my sketch exactly where I need it to be. Finish the sketch. You want to talk to Brother Vincent quick?
Sure.
We're going to do our extrusion. Now for the bottom, negative material thickness. Negative. We're cutting. Great. So now our 2 legs interlock the way we expect them to. We're good to go. So last thing we need to do is actually create the seat. We're going to create a new sketch. We set this up from the beginning that we would be able to sketch right on this plane. And we're going to do a center circle. Look, all our geometry is perfectly aligned so that the center is exactly the center of each board because we extruded on both sides symmetrically. All that stuff is good. We're going to click here. You can create a parameter called seat diameter, or since this is really the only place that I'm going to put it, I could just type right in this box. Now, key thing is that we never want this to be wider than the base of our stool, right? Think about it. If you were sitting up here, if it was way bigger than the base of our stool, it's going to be very easy to tip this over. So maybe you want your diameter to be related to that bottom number. That's fine too. Just for quickness right now, I'm just going to put this at a number. Let's try 17. And really, I should be thinking a little bit more carefully about this, because if I'm changing the angle of the stool, or, there's definitely, if I fix this at 17, there's a chance my legs could be wider than it. Or, that wouldn't be great. Brendan, you had a question? Or
Say you take the width of however long one of those are.
Yep.
And then divide by 2. for the radius.
Sure. So what number is that though? I think we had stool height, cross brace height. We had something with the bottom. Leg width. Not sure. I'm not sure what the name was. We could look it up, but I'm okay with just starting here. We'll just put a number in. We can always fix this later. Now I have my sketch started. The next thing I need to do is put the tabs in. Now you got to be careful because there's a lot of rectangles here and you got to think through what's what. But I can see that this long part is the tab. These little rectangles, they're the edges of the leg. That would be kind of like the stool is sitting on. This wide rectangle, that's the angled side of the leg that goes all the way to the floor. So this right end here, that's the bottom of the leg that's touching the floor. It's way below the seat. Does that make sense? So this is where all that orthographic projection stuff kind of comes back into play. And now I know I want this rectangle and I want it to be locked to the corner here. Hold on, I can't lock to the corner. I can't lock to that rectangle. So what do I need to do? I need to project that geometry. So we're gonna go create. We're gonna say project include, and I'm gonna say project. And I actually can just click on the rectangle itself. I can click on it. Now, technically I could click on all four and I'd be done. But I wanna show you one more tool. So this is fine. I could say this and I could say, hit okay. And there I have all my geometry I need. This is probably the right way to do it. But I wanna show you one more tool. So I'm gonna undo that. I'm gonna project one of them. And then I'm gonna show you. So project one, hit okay. And we've done something called a rectangular pattern before, where you could say, I want this many of them across and this many of them vertically, and you make a grid. Well, we can make a circular pattern in a similar way, where we select a geometry and we can rotate it around the point. So we go circular pattern, and I can collect all 4 corners and 4 sides. So I have 8 parts to that rectangle. And then I can say center point. What do I want to rotate around? I'll just rotate around the origin. And we can change this number. How many of them do we want? And it just evenly spaces them. It's great. Obviously, we don't need that many, but I also wanted to show we can tell it an angle to go around. So in this case, I'm going only 180. I have 9 of them across the whole 180. It's kind of nice. Let's switch this back. We need 4 of them. And we need it the full way around. And there they are, 1, 2, 3, 4. They all line up perfectly in the right place. Finish my sketch, and there I am. I'm done. So last thing I'm going to do is select the geometry that I want to extrude. Let's change the view so we can see it actually extrude. And how far do we want to extrude it? Material thickness. Whoops. Whoa. Let's try that again. Click on the geometry, choose the distance, material thickness, hit enter. Looks good. Look at it from the side. Hit OK. Look at it from the top again. Uh-oh. I lost the holes. What happened? Let's go back into that step. I'm going to edit that feature. And when I look at my properties list, I can see it here at the bottom. My operation is join. So when I extruded that, because it was touching other parts, the 2 legs, it made it part of the legs. We don't want it to be, we need this to be its own part, right? So how do we make it its own part? Instead of having join here, we just say new body. And now this is going to be a 3rd body. We'll have 1 leg, 2nd leg, and the seat. Hit OK. Now I can still see the holes for the legs. So far making sense? All right, so the next thing I want to talk to you guys about is dog boning. The truth is that these things won't be able to perfectly lock together because of how we're manufacturing this. We're using a CNC machine, right? CNC machine cuts with a round bit, okay? think of a drill bit. I have one here, I'll show you guys. This is a ball nose end mill. So we call these end mills, or we can also use router bits. But they're drill bits that are strong enough and sharp enough that instead of just being able to go up and down, make holes, you can go down and then you can move it sideways to cut like a saw would cut. But it's going to be this thickness. That's what you're cutting out of your material, the thickness of your end mill. So when we do cutting like that, if you guys want to pass that around. We end up with a problem. Okay, so here is a corner that we want to cut. And this circle here, this is pretending we have this as our end mill. And it's cutting a straight line and all good. It's making a perfect cut. But when it gets to the corner, what happens? Yeah, it can't cut out the corner. So we're stuck with some material in here. I'm going to kind of try and highlight that. So here is my material that I want removed, but I can't reach. And then we can kind of continue along. Oops. And we cut. And all good. So this isn't the worst thing in the world, especially in certain places. For example, the legs, it's a corner just like this. That doesn't have to be a 90 degree. I actually put a radius there so that we can easily cut this on the machine, right? My machine has no problem cutting that nice curved part. But the problem becomes when you want to slide two boards together and lock them in. If I have a board that needs to come down, going to fit here, and it's going to slide down. Let's move my fit. It's sliding down, but we want it to actually touch that cross brace. We're going to hit a piece of material here. We're not going to be able to slide it all the way down. So what do we need to do? We need to cut that material out. And how do we do that? Well, there's a few ways. We could just cut this and cut to here, and then come back up and then cut over. And we'd have like a little line cut past the edge. That would be fine. But there's actually a special type of cut called a dog bone cut, okay? And what it is basically we cut that material out with the bit in the corner. And a lot of people think, why don't we just center it right on the corner? So we say, this circle center is right here. And that would totally work. But remember, these bits are cutting sideways. I couldn't get the bit to this location. Why not? Because if it was cutting sideways, we only have, basically, you're going to tell it, here, cut this shape out. And now, you only have this dotted line to fit through. That opening is not wide enough for the red bit to come in. So it'd have to cut everything, then it'd have to lift up, go to that location, and then drill down like a drill. Totally doable, but there's a more efficient way to do this. So what we do is we cut just far enough so that the corner of our geometry is exactly at the edge of our bit. And now look at the distance. It can fit in there. There's no problem reaching that spot. So how do we create that geometry? Using fusion and constraining things, and where is this actually located? there's a few things we can think about. The first is the edge of my red circle, the cutting bit, needs to be right at the corner here. So that has to be, what do we call that when we lock a point to a line or a point to a point?
Snapping it.
Snapping it, but we call it coincident. There's like a coincident constraint where you say these things have to be in the same place. So we can make that corner coincident with the edge. But there's lots of ways to do that, right? This circle could be here, here. It's all of these work. All of these have that circle at that point. So there's more to it than that. Basically, we want this circle to be symmetric. We don't want it to be offset to one side. We want it to be exactly so that there's like equal amount hanging over on each side. How do we do that? That's trickier.
We use triangles.
Any thoughts?
We could, like, what's it called? Make two lines that go to the center of, like, where the
Oh,
circle
sorry,
is.
sorry. I couldn't hear you on the computer. Go ahead, say it again.
Oh, what's it called? You could either use like a couple of triangles, or like and so like if you use the diameter of the circle as this as the hypotenuse of the circle, and then have the corner be the one of the corners of the triangle, and then have the two other sides of the triangle be equal, then you can have that separate. That's the same.
So yeah, so I'm gonna say that out loud because there's a little quiet. Basically, you're saying something like this, like there's a line from here to the center of the circle, and we just need to make sure that this purple line and this purple line have equal lengths. That's a good way to say it. What I'm gonna show you a slightly different way to do that is we're going to take a circle and we're going to make it so that it's tangent. We're going to make it that cut that we said basically doesn't work. Then we're going to say, let's make a construction line from that circle to this corner. Now I have that dotted line that's a construction line. And as long as I make my next circle so that its center is on here and its edge is on that point, we get the geometry that we exactly want. Not what I'm drawing, but you can imagine. So now this point has to be on that line. Edge of our circle has to be at the corner, and we're locked in place. So let's see what that looks like on the computer. It'll make a little more sense when we draw it out. Let me stop sharing on my iPad. Thank you, sir. Let's do the seat is going to be a nice place to do this. We're going to edit this sketch and we'll look at one of these corners. Let's hide the objects and we'll go all the way in to this corner. Now, the first thing we're going to do, before I do any of this, the size of our dog bone is always going to match the diameter of our drill bit, or end mill, I should say. So we're going to change parameter and we're going to say end mill diameter is going to be in case we use different tools, we could always just change all of the dog bones. So end mill diameter. And how big do we want it? Well, standard one, probably the one we'll use is 1/4 inch. So I'll say okay. And now I'm going to use the circle tool, but I'm going to make that circle tangent to two of the sides. And this is a little tricky, but when you use this tool, instead of a diameter, it's a radius. So I'm going to say end mill diameter divided by 2. Okay. So now I can create a line from the center to the corner, and all that stuff is going to just be construction lines. I'm going to click both, holding shift, then I'm just going to hit X. So now they're construction lines. And now my next circle, I want it to be on this construction line. So I'm going to start it here. Now I'm going to just drag it out and I'm going to make it diameter, end mill diameter, hit enter. We're very close I'm going to hit enter again, but it's blue. Why is it blue? It's blue because I haven't constrained it. It can kind of be anywhere on this line, but we want to snap it in place. We want where the edge is locked to that corner. So I'm going to use the coincident constraint. The circle is selected, click coincident, and then I'm going to click on the corner, and it's locked in place now. And when I say finish sketch, if I go to my feature where I extruded this seat and I edit it, and I just remove these corners from my extrusion, hit enter. Now, you can see that my dog bone is cut large enough so that this tab will fit in there. Now that's a lot of geometry to add in a lot of places. So because this is such a common thing, instead of having to do all of that geometry over and over and over again, right? All this, what we would have to do? A circle and a second circle and a construction line over and over. We end up creating a tool that lets us do that basically automatically. Have you guys ever heard of like a plugin for a program? Just kind of like an addition, an add-on that increases functionality for it. Well, there's a dog bone plugin that we'll get and we'll download and we'll install. It's not on the computers yet because you're the first ones using Fusion 360 on this set of computers. And instead of having to go through the geometry, we'll just click on one of those inside corners, tell it what radius we want it to be, and it'll automatically make it, just like all the other features that we have. You just click on it, it'll be in one of our toolbars, and you'll get a little pop-up that has some options, and it's an automatic thing. So that'll be our next class because we have to actually go and find that and download that plugin. So we'll stop there. And you guys, we got about 7 minutes left. Hopefully you can work on your sketches, get them up to what we've done so far in class together so that you're ready for the next step tomorrow. Any questions at home, guys?